Hey everyone, so here's the last part for our lesson 2 notes. So we're kind of just taking rational functions and applying it to a real-world example here. So it says example 8, a 3D printer builds up layers of materials to make three-dimensional models. Now each deposited layer bonds to the layer below it. A company decides to make small display models of engine components using a 3D printer. So the printer costs $24, and then after that, the material for each model will cost $300. So part A says we need to write an equation that gives the average cost per model as a function of the number of models printed. Okay, now when we are doing these problems, first we need to define the variables because they don't show us. So we can use X and Y, we can use anything else. I do notice that they talk about writing an equation that gives the average cost per model as a function of the number of models. So it looks like we're kind of comparing the cost with number of models. So I'm going to go ahead and define my variables as C for the cost, and then M as the number of models you have to make. Okay, so the thing is, the number of models affects what your cost is, right? How much the average of that cost is. So that means C is going to really represent our Y values, M is going to represent those X values. Okay, now next we got to write an equation using these two. Now notice here it talks about the average. Well, think about, what does average mean? Okay, how do we calculate average? Well, average, we should be able to calculate it by taking the total amount dividing by how many there are. So what we need to think about, if we're doing average cost, we got to think about, well, okay, what is the cost of, like, because they talked about the cost of the printer, so that has to be in for it. The material for each model, what that cost is, okay? And really think about, well, then how many models are we making? So our total cost, right, is going to be, first, we have a fixed amount for the printer, $24,000, and then each model is going to cost $300. So what that really represents is that we have $300M to say, well, if we have one model, it costs $300 for the material. 2 models, it costs $600 for the material. 3 models cost $900 for the material, and so forth. And then we added to that kind of fixed rate because we had to pay for a printer. Now we take that cost and we divide by how many, well, models we have. So it'll be divided by M. Okay, so now let's part B. So it says graph the function, and we're going to use the graph to estimate how many models must be printed for the average cost per model to fall to $700. Now, let's think about this. When they say the average cost per model to fall 700, we got to think about, okay, is that 700 representing the C or the M? Well, it is the C value because it's that average cost. So we have 700 equals 300M plus 24,000 all over M, okay? Okay, so we are trying to find basically the M. So basically how many models must be printed for the average cost to be 700. Now we've actually done this in class before. It's been a while, but what we're going to do is actually plug both of these into our graphing calculator, and we're going to take 700, plug into Y1, and then this function into Y2, and what we're going to do is figure out the intersection. So use the intersection feature to find the M value. So let's go ahead and do that. So probably some good review of our graphing calculator stuff. Okay, so press Y equals. Make sure if you need to clear any functions, make sure you do that. So just press the clear. I do 700. And then, now if you have an older version of your graphing calculator, you'll have to use parentheses. So you'll have to do parentheses, and then it'll be 300M, or in this case, since we don't have M, we use X. Okay, then plus 24,000, and your parentheses, then divided by, and then you just put X. So if you have an older version, you're going to have to put it just like this using your parentheses. And remember, we're going to have to use X because there you don't, that's really the variable to use in the graphing calculator. Now, if you have a newer or updated version, you can do alpha Y equals. use that fraction feature and then just put it in as so, and you don't have to use parentheses when you use this fraction feature. It is only when you don't use it, you got to use parentheses, okay? Now, here's the thing. Probably your window is from -10 to +10 on both the x and y axes. We should know if that we're going to have 700, this is going to create a horizontal line. Our y max has to change, okay? So I'm already going to go to window, and I know my y max is going to have to be bigger or at exactly 700, or you can make it bigger. I'm going to make it 800. I'm going to do this. I'm going to go by tens on my y scale so I don't have as many of those little lines there. Now I'm going to press graph to see. Okay, now I do see my horizontal. I do not see the other one. So that means I do need to make something bigger. I don't think I need to make the y's because we can definitely see the horizontal. It's my x's and the max, right? So let's do this. I'm going to make, because I do not know what this is going to be, I'm just going to make it the same as the y max. And then make my x scale 10 just to see. Ah, there we go. Okay, so now we see the intersection. So remember we press second trace, go to number 5 intersect, and then don't forget to press enter 3 times. 1, 2, 3. And then we're looking at the x. X is our m, which represents basically the models. So x equals 60 here. So when it talks about 60, what this is saying is that we have to make about 60 models, or 60 models must be printed in order for the average cost per model to fall to about 700 there. Okay, so then our next thing that we're going to do here, see what happens to the average cost as more models are printed, okay? So what this is really, and we think about this, right? This is a rational function. And so because it's a rational function in actually the form of ax plus b over cx plus d, we have to think of in regards to our vertical and horizontal asymptotes. And that's going to help us to actually answer part C. So I am drawing a sketch of this function. It's not going to be the best, okay? So as I stated, it's going to be that. So let me just rewrite the function so I know what it is and find some of the important information. So what we need to find here for the asymptotes, horizontal, remember because it's in the form of ax plus b over cx plus d. To find that horizontal asymptote, I'm going to need a over c. And so that is 300 over 1, which means the horizontal asymptote is at 300. So let's just say this is 300 right here. So we got a horizontal asymptote, okay? So for the vertical, let's just see what that looks like. Remember, we set the denominator equal to 0. Okay, well, it's just 0. So basically, it's this. So our graph is going to go something like this, okay? As we can tell from our graphing calculator as well. So notice here is what our rational function looks like. So I'm kind of just sketching that. Okay, so we can see that our graph is getting towards a value, and actually it's getting towards, it looks like 300. So basically, as more models are being printed, the average cost approaches $300 because that's representing our horizontal asymptote. Okay, just let me know if you have any questions. See you guys later.